Everyone knows the 8 survivors. Almost nobody asks about the 17 that didn't make it, or what happened to them between retirement and disappearance. Union Pacific's official motive power rosters document exactly 25 of these 4884 articulated locomotives, delivered in 2 distinct production runs between 1941 and 1944. 8 of these machines remain accounted for, secured in museums and public parks across the country. But the remaining 17 present a different kind of challenge, one of administrative tracking and physical paper trails. Finding where they went requires bypassing internet folklore and returning to the primary ledger entries maintained by the railroad's mechanical department. The period between the final drop of steam pressure in 1959 and the ultimate clearing of the tracks in 1963 is recorded not in memories, but in equipment cards, retirement ledgers, and official work orders. In these files, the fate of each locomotive falls under specific administrative headings: stored, vacated, donated, or sold for scrap. The term disposition carried legal and financial weight for Union Pacific management. An engine was not simply cut up, it was systematically retired from the active roster, evaluated for its remaining material value, and processed through corporate approval chains. These official records, specifically the railroad's own retirement cards and Form 457 disposal logs, document the exact timeline of the 17 lost locomotives. This is a story of corporate accounting, where half-million-pound machines were reduced to ink on ledger lines before they ever met the cutter's torch. The mechanical designation for these machines is the 4884 wheel arrangement, a classification system indicating the physical layout of the locomotive's chassis. At the front, a 4-wheel leading truck guides the engine into turns. Behind it sit 2 separate groups of 8 driving wheels, followed by a 4-wheel trailing truck that supports the massive firebox. This layout relies on an articulated construction, featuring a hinged frame that allows the long, rigid boiler section to flex dynamically while negotiating curves. Without this jointed frame, a locomotive of this scale would simply derail on standard mainline curves. Designed under the leadership of Otto Jabelmann, head of Union Pacific's Department of Research and Mechanical Standards, the 4000 class was engineered to solve a specific operational bottleneck. Before their arrival, heavy trains crossing the steep grades of Sherman Hill required helper engines, defined as additional assisting locomotives coupled to the train to provide the necessary climbing power. These assisting units added substantial labor, scheduling complexity, and fuel costs to every run. Jabelmann's design aimed to eliminate these helper operations entirely, allowing a single crew to move heavy tonnage over the pass unassisted. The American Locomotive Company, or ALCO, built the 25 engines at its Schenectady plant in 2 production runs. The first batch of 10, numbered 4000 through 4009, was delivered in 1941 to meet the initial demands of the Western route. The second batch of 15, numbered 4010 through 4024, followed in 1944 as wartime freight traffic reached its peak. These units represent the largest steam locomotives ever placed in regular service anywhere in the world, specifically proportioned to operate within the physical constraints of Union Pacific's existing tunnels and yard facilities. Together with the tender, a big boy measures approximately 133 feet in length and weighs nearly 1.2 million pounds. The boiler operates at a pressure of 300 pounds per square inch, generating a calculated tractive effort of 135,000 pounds force. These technical specifications translated directly into raw pulling capability, giving Union Pacific a single machine that could handle the heaviest transcontinental freight loads on its own. It is this specific combination of articulation, high boiler pressure, and massive tractive weight that defined the mechanical profile of the class, providing the exact engineering parameters found in the railroad's archival ledger entries. Understanding these physical dimensions and mechanical systems is necessary before analyzing how these machines performed under actual operational conditions. The Wyoming Division was the specific territory these locomotives were engineered to conquer. This mainline corridor stretched from Ogden, Utah, through Green River, Wyoming, and ended at Cheyenne, a distance of roughly 176 miles across some of the most unforgiving terrain in North America. The geography of the Wasatch Range presented a continuous obstacle course of elevation and grade. At Ogden, the track sat at 4,300 feet. From there, eastbound trains faced a relentless climb, rising 3,000 vertical feet to reach the Aspen Tunnel, which pierced the mountain ridge at an elevation of approximately 7,300 feet. After clearing this summit, the line descended to 6,100 feet at Green River, before rising again to challenge the Continental Divide. Climbing these mountain passes meant fighting grades that approached 2%. In railroad engineering, a 2% grade is a severe obstacle. For every 100 feet of forward movement, the track rises 2 vertical feet. When pulling heavy freight, this incline multiplied the physical resistance on a train exponentially. Before these locomotives arrived, Union Pacific could only cross these barriers by coupling up to 3 helper engines to a single train. This practice required extra crews, complex scheduling, and frequent stops to attach and detach helper units at the base and summit of each climb. The 4000 class engines were not general-purpose locomotives built to roam the entire system as promotional showpieces. They were highly specialized, purpose-built tools designed for this single mountain corridor. Their physical dimensions were tailored to the specific curvature and clearance limits of these tunnels and passes. By restricting their regular service to this localized mountain division, Union Pacific placed its most powerful machinery exactly where the physics of grade and weight demanded it most. The entry of the United States into World War II placed heavy demands on the nation's rail network, turning the Wyoming division into a primary transcontinental corridor. Raw materials and finished war supplies had to move west, while troop trains and industrial steel surged east. This was the environment where the new locomotives proved their design. Day after day, the engines hauled massive trains weighing between 5,000 and 6,000 tons over the steep grades without assistance, maintaining tight schedules under intense wartime pressure. By the time the war ended, these machines had established themselves as the backbone of the railroad's heavy freight operations. Their reliability under heavy loads was recorded in daily station logs. Operating books kept by engineers and firemen detailed how these engines handled heavy coal, iron ore, and steel shipments across the high plains. The physical toll of this constant service was immense. By the end of their working careers, individual locomotives accumulated between 800,000 and 1 million miles of travel. Locomotive 4014 alone logged exactly 1,031,205 miles during its active service. The reputation of the class grew directly from this performance. Crew reports praised the engine's steady steam production and predictable handling under extreme loads. Engineers noted that the locomotives remained stable even when pulling maximum tonnage through freezing mountain winters. This practical reliability secured their status within the company long before they became historical icons. They remained the choice for the heaviest tonnage throughout the late 1940s and into the 1950s, proving that their design met every operational demand the railroad encountered during its period of heaviest traffic. By the early 1950s, the ground beneath the steam fleet began to change. The decline of the 4000 class had nothing to do with mechanical failure on the steep grades of Sherman Hill. No structural defects or design flaws limited their work. Physically, these locomotives remained as capable of pulling 6,000-ton trains in the late 1950s as they had during their wartime peak. Instead, their removal from the active roster was driven by a fundamental change in how the railroad organized its entire motive power fleet. Post-war diesel-electric locomotives altered the basic math of railroad operations. Steam engines required distinct designs for passenger, fast freight, and heavy mountain work. By comparison, diesel units were modular. A railroad could couple 3 or 4 diesel units together to match the tonnage of a specific train, then separate them to run on lighter branch lines. Because of their extreme weight, the 4000 class engines were restricted to the heavy main line, unable to venture onto branch lines. A diesel fleet could go anywhere, standardizing maintenance across the entire railroad. This operational flexibility directly challenged the single-purpose design of the big boy. Union Pacific's fleet strategy increasingly prioritized daily availability. A steam locomotive required hours of preparation, firebox cleaning, and lubrication before each run, followed by intensive boiler maintenance afterward. Diesels could run for days with minimal servicing, offering much higher utilization rates. The big boys were built for a specific support network of coal chutes, ash pits, water treatment plants, and large roundhouse crews stationed across the Wyoming division. Maintaining this labor-intensive infrastructure alongside a new diesel network created an expensive duplicate system. Internal accounting comparisons from the late 1950s showed that the total operating cost per ton-mile for a big boy was 3 to 4 times higher than a comparable diesel fleet. The locomotives remained physically powerful, but the support system required to run them had become economically obsolete. The physical cost of operating a steam locomotive extended far past the price of the fuel itself. To keep a single 40,000 series engine in motion, Union Pacific had to maintain a vast labor-intensive support network across the entire Wyoming division. On a typical run, a big boy consumed approximately 5 tons of coal and 10,000 gallons of water for every 100 miles traveled. This massive rate of consumption turned water stops along the route into absolute operational necessities rather than occasional servicing pauses. To satisfy this demand, the railroad maintained high-capacity water tanks, wells, pumping stations, and chemical treatment plants to prevent scale buildup inside the boilers. Each of these facilities required constant upkeep, winter heating, and manual oversight. Coal delivery presented another massive logistical footprint. Coaling towers, some built of reinforced concrete rising high above the tracks, required dedicated crews to manage coal deliveries, operate conveyor machinery, and load the tenders. But loading fuel was only half of the cycle. At key yards, hostlers and cleanup crews had to clear the heavy ash pans beneath the fireboxes, shovel waste into wet ash pits, and systematically clear the residue of combustion from the engine's internals. Inside the roundhouses at Cheyenne, Laramie, and Green River, the labor demands multiplied. Every incoming engine required inspection by specialized machinists, boiler makers, and pipe fitters. Boilers had to be cooled, washed out to remove sediment, and fired back up over several hours to avoid thermal shock to the steel. Lubrication was a continuous task. Grease cups had to be refilled and mechanical lubricators checked before every departure. The sheer physical size of the locomotives meant that even routine inspections required specialized cranes, scaffolding, and dozens of workers. These expenses are consolidated in a metric known as the cost per ton mile, defined as the total expense of moving 1 ton of freight over a distance of 1 mile. This calculation includes fuel, water, crew wages, terminal servicing, and track maintenance. Diesel-electric units shattered this economic model. A diesel engine required no coaling towers, no water stops, and no ash pits. By coupling multiple diesel units together, a railroad could run an entire division with only a fraction of the support infrastructure and labor required to keep steam alive. While historical ledger records from this transitional period are subject to verification of the accounting basis, contemporary estimates indicate that operating a steam fleet cost roughly 3 to 4 times more per ton mile than running modern diesel locomotives on the same routes. The big boy was a marvel of heavy engineering, but it was ultimately defeated by the inescapable cost of the ground network that kept it alive. On June 7, 1959, Union Pacific began what would be the final scheduled revenue season for the big boy class. Over the next 6 weeks, 6 of the locomotives, numbers 4011, 4014, 4015, 4017, 4019, and 4023, completed 45 round trips between Cheyenne and Laramie. When the last of these runs ended on July 21st, it marked the quiet end of scheduled steam operations on the Wyoming division, yet it did not mean the immediate destruction of the fleet. Instead of being sent directly to the scrap line, these engines were placed into a state of suspended animation. Union Pacific chose to store the locomotives rather than dismantle them, establishing a reliable strategic reserve of operational insurance. The railroad was still evaluating the long-term reliability of its new diesel-electric fleet, especially during peak transcontinental traffic periods and severe winter weather. By holding the massive 4884 locomotives in reserve, management maintained an emergency fallback option. This interim strategy resulted in a specific distribution of the 25 locomotives across the division. At the peak of this storage period, 6 big boys were parked inside the roundhouse at Green River, 4 were held at Laramie, and the remaining 15 were kept at the main terminal in Cheyenne. Over time, these numbers shifted. By late April of 1959, for instance, only locomotives 4000 and 4005 remained at Green River, with the others consolidated toward Cheyenne. For approximately 26 months, these 17 now silent giants sat intact and maintained under shelter. They were protected from the elements, their heavy boilers drained, and their moving parts thoroughly greased. These massive physical machines remained fully capable of returning to the rails if the diesel fleet faltered. This period of quiet custody separated the end of regular service from the formal administrative decisions that would follow. It was a temporary reprieve, keeping 25 of the world's largest steam engines physically preserved while their corporate owners carefully watched the performance of the new diesels that had replaced them on the mountain. By the autumn of 1961, the emergency fallback strategy had run its course. Peak traffic subsided, and the newly acquired diesel-electric fleet proved dependable enough to handle the workload through the harsh Wyoming winters. The insurance policy was no longer necessary. In the eyes of Union Pacific's accounting department, the 17 stored non-operational big boys ceased to be active locomotives and became non-earning assets occupying premium yard space. The institutional question shifted from whether these machines could still run to what these idle assets were worth. Each complete locomotive and tender weighed approximately 1.2 million pounds. At 600 tons apiece, they represented a massive concentration of high-grade steel, copper, and brass. Under corporate guidelines, surplus property was defined as equipment no longer required by the current operating plan. Management now viewed these silent giants as real estate obstacles requiring active maintenance and supervision. In late 1961, Union Pacific initiated a formal disposal program. This administrative step was separate from the physical act of dismantling. It was a paper transaction that stripped the locomotives of their operational identity. Mechanical department clerks began processing the retirement cards, officially stamping the equipment records as vacated. This wave of formal retirement documentation spanned from December 1961 into February 1962. Locomotive 4015 led the transition, vacated for scrap in September 1961. One by one, the ledger entries transformed these engines into simple line items on a residual value balance sheet waiting for the final disposition. When Union Pacific removed these locomotives from the active roster, they remained on railroad property, but physical custody did not equal long-term protection. An engine held in a yard or roundhouse was simply surplus property awaiting its turn on the scrap line. The railroad's primary obligation was to its shareholders, not to historical preservation, meaning that any machine left under corporate control possessed no legal shield against destruction. Survival required a complete break from the railroad's administrative system. Only a formal transfer of ownership to an external entity created a viable path to preservation. When Union Pacific chose to donate an engine to a municipality, a museum, or a historical society, it established an entirely separate chain of custody and responsibility. This act of public donation legally severed the locomotive from the active scrap program, shifting the burden of care, display, and maintenance to the receiving institution. The paperwork governing these transfers was precise. The donation agreements typically required the new owners to place the locomotives on static, non-operational display, and to maintain them at a specific, agreed-upon location. These contracts drew a sharp line between legal title, physical possession, and maintenance liability. Some contemporary accounts suggest that these agreements included specific reacquisition clauses, giving the railroad the right to reclaim the locomotives under certain conditions, though these provisions require verification against the original archived documents. Without these signed deeds and completed transfers, the locomotives remaining in Union Pacific yards possessed no future. They were treated as collections of valuable raw materials occupying prime space vulnerable to the immediate needs of the business. The paperwork of donation was the only line of defense, separating the locomotives destined for public parks from those that would soon face the dismantling crews. In September 1961, the physical destruction of the retired fleet began. Locomotive 4015 was the first to face the cutter's torch at the Cheyenne scrap dock, just weeks after its formal retirement. 14 of the non-preserved locomotives met their end inside the Union Pacific yards at Cheyenne. The railroad contracted the Union Steel Corporation to handle this bulk dismantling work. Yard crews used heavy lifting equipment, overhead cranes, and oxyacetylene torches to systematically dissect the 600-ton machines. The work followed a standard sequence. Workers separated the tender from the engine, stripped the outer casing and insulation, and then cut the massive boiler, frame, and running gear into smaller sections ready for the furnace. While contemporary estimates suggest this process took roughly 2 to 3 weeks per locomotive, the exact day-to-day work orders remain unverified. The remaining 3 units, 4003, 4010, and 4020, followed a different route. Union Pacific sold these engines to Luria Brothers and Company, which forwarded them to Utah Metal Reclaimers. They were towed to the Columbia Geneva Steel Corporation plant near Provo, Utah, for demolition. The precise timing of their destruction reveals conflicts in surviving records. While some railroad disposal logs list their final scrapping in May 1963, other internal correspondence indicates they were moved from Cheyenne in late 1961 and cut up in early 1962. This mismatch in dates illustrates the difficulty of tracking surplus equipment once it left Union Pacific's immediate custody. These tracking challenges are compounded by errors in later accounts, including persistent rumors of a 26th locomotive numbered 4025. Union Pacific's mechanical records and original builder sheets from the American Locomotive Company confirm that the class ended at 4024. No locomotive 4025 was ever built, and references to it in public forums are the result of clerical errors or misidentified photographs. By the summer of 1963, the final cuts were completed. At the Cheyenne Yards and the Provo Steel Plant, 17 of the world's largest steam engines had been reduced to piles of industrial salvage, their high-grade steel, copper, and brass fed directly into open hearth furnaces. In the early 1960s, Union Pacific's ledger books reduced these 600-ton machines to a single, cold metric: scrap value. At the time, the market price for heavy melting steel scrap hovered around $30 per ton. For a big boy, this translated to a raw material estimate of roughly $24,000, climbing to nearly $50,000 once valuable brass fittings, copper tubes, and administrative write-offs were factored in. This final figure did not represent a confirmed sale price for an individual engine, but rather the baseline value of the physical commodities locked inside their massive frames. To the railroad's accounting department, a retired locomotive was not an industrial monument or a cultural legend. It was a depreciated asset occupying valuable track space. The The calculation measured only what the steel, copper, and iron would fetch in an open hearth furnace. It did not account for original construction costs, the price of modern replacement, or the intangible weight of history. Yet, as the last of the 17 locomotives were reduced to scrap, a parallel economy began to grow. Over the following decades, the public memory of the 4000 class evolved. A thriving preservation movement, model train manufacturing, and heritage tourism would eventually value these machines at millions of dollars apiece. In 1961, however, Union Pacific acted on the immediate reality of their balance sheets. The decision-makers of the era could not trade in future nostalgia. They saw only 600 tons of obsolete machinery worth more to the railroad as raw metal than as silent monuments to a bygone era. The physical survival of the 8 remaining big boys was not a coordinated rescue of the most historic or deserving locomotives. It was entirely a matter of administrative timing. Between late 1964 and 1965, Union Pacific opened a narrow window where the railroad was willing to donate surplus locomotives to municipalities, museums, and historical societies rather than send them to the scrap line. If a formal request, a viable display site, and a clear transport plan came together before the cutter's torch arrived, the corporate disposal system could be legally interrupted. This paper trail of donation agreements, rather than sentimentality, saved the survivors. For the receiving institutions, accepting a 600-ton machine meant resolving massive logistical challenges before taking physical title. Municipalities and museum boards had to coordinate site preparation, lay concrete foundations, secure track access, and commit to long-term maintenance. The city of Cheyenne accepted 4004 for Holiday Park, anchoring the locomotive to its historic home base. In 1964, F. Nelson Blount used his private resources and nonprofit Steamtown Foundation to secure 4012, moving it to Vermont before its eventual transfer to Scranton, Pennsylvania. Other institutional arrangements secured 4017 for Green Bay, Wisconsin, and 4018 for Texas. Locomotives 4005 and 4006 found homes with the Forney Museum in Denver and the National Museum of Transportation in St. Louis. Engine 4023 was eventually secured for display in Omaha. Yet these agreements did not guarantee a return to glory. The contracts signed by Union Pacific and these receiving organizations drew a strict line between legal title and physical possession, requiring the locomotives to remain on static, non-operational display. For nearly all of the survivors, this preservation meant a permanent end to their working lives. They were greased, painted, and stabilized, preserved not as living machines but as silent, static monuments to an era of railroading that had already vanished. In January 1962, Union Pacific delivered locomotive 4014 to the Southern California chapter of the Railway and Locomotive Historical Society in Pomona, California. For over 50 years, the engine sat as a static monument at the Los Angeles County Fairplex, its heavy running gear greased and its boiler cold. To the public, it was another permanent survivor of a bygone era. But static display and operational restoration represent two entirely different undertakings. While 7 of the remaining big boys remained locked in their roles as historical monuments, 4014 was destined for an unexpected reversal. On July 23, 2013, Union Pacific announced a formal agreement to reacquire 4014. This move relied on specific provisions in the original 1962 donation agreement that allowed the railroad to reclaim the engine. In early 2014, crews prepared the massive locomotive for a return trip to Wyoming, towing it back to the Cheyenne steam shop where its transformation began. The modern restoration required a complete industrial overhaul instead of a cosmetic cleanup. Work at the Cheyenne shop demanded systematic disassembly. Boilermakers and machinists rebuilt the pressure vessel, overhauled the driving wheels, and upgraded the braking systems. The project also required modern engineering adaptations. crews converted the firebox from coal firing to oil firing, aligning it with Union Pacific's current heritage fleet. Technicians also installed modern safety equipment, including positive train control electronics, to allow the steam locomotive to operate on busy 21st century main lines. While external estimates of the total project cost vary from $7 million to several times that amount, Union Pacific maintains the exact financial figures as proprietary corporate data. Similarly, conflicting public records surrounding the exact transfer dates, oil conversion parameters, and modern safety integration details remain subject to ongoing historical verification. On May 1, 2019, locomotive 4014 moved under its own steam pressure for the first time in nearly 6 decades. The engine returned to active service later that month, participating in the sesquicentennial celebration of the Golden Spike completion. Today, 4014 stands as the only operating 4884 locomotive in existence. Yet this modern achievement remains separate from the historical economics that ended the steam era. While 4014 travels the country as a corporate ambassador, it operates within a specialized heritage program, demonstrating the mechanical prowess of the past without changing the cold, operational math that led to its retirement decades ago. The disappearance of the 17 big boys was not the result of a sudden mystery or corporate conspiracy, but the predictable outcome of standard business procedures. In the early 1960s, Union Pacific officers operated under strict accounting guidelines where an obsolete steam locomotive was simply an unproductive physical asset holding a specific scrap value. The long-term cultural value and historical significance that define these engines today were entirely absent from the accounting metrics of the era. Of the 25 original machines constructed to conquer the grades of the Wyoming division, 8 were ultimately secured for static display and heritage roles, while 17 were systematically processed through standard retirement and salvage contracts. This division of the fleet represents a rational compromise between public stewardship and industrial reality. Today, as the sole operating survivor travels the modern rail network, the story invites a broader reflection on how societies define and measure value over time. Faced with the same economic pressures, duplicate maintenance networks, and rising scrap metal prices, it remains an open question whether a modern transportation company would make a different decision today. We stand before the sole operating survivor, a living exception to a cold corporate rule. The destruction of the 17 wasn't a mistake. It was the logical result of an era that measured progress in ledger lines. Today we worship the steel we once priced by the ton. If faced with the same balance sheets today, would we choose history or the scrap heap? Share your thoughts below.